In this video, we're going to have a look at this 2021 Level 2 Physics waves questions. I'm going to focus on the ones that you found hard in that test, those of you who have done it, which was refraction and some of the ray diagrams. So let's look at this one first. I'll let you read the question. So it's saying to name the phenomenon that is occurring at the glass-air boundary. So let's find the glass. There's the glass. This is the air, as you can see from here. So what they're talking about is there and here. So name the physics phenomenon occurring where you're getting total internal reflection. Obviously write it in words. Common mistake in the exam, some of you said total internal refraction. That's wrong. It's a reflection. So total internal reflection. How do you notice that? Well, all the light's being reflected. Refraction is when the light bends. There's no bending here. It's just reflection at that surface. Remember, total internal reflection happens when you go from more dense to less dense, and when the angle of incidence is greater than the critical angle. So both of those must be true. Next question gets you to calculate the critical angle. So for this, you go to your formula sheet and use this equation. Now, the first thing to realise is we've been given quite a bit of information here, and we're focusing on this part here where the ray hits the boundary. So what we are doing is we're going from glass to air. So glass is number one, air is number two. Remember, the one refers to the first material, two is the second. So N1 is the refractive index of glass, that's 1.52. The critical angle is the angle that it's coming in at, so that's this here. I'm just going to replace that with a C. It's going into air, so that's the 1, times sine. Now, this angle here, you've got to remember, if it's a critical angle, definition of that is the angle of incidence, this angle here, when the angle of refraction, or angle 2, is 90 degrees. Just learn that. So 90 goes in here. What you'll then do is type that into your calculator, or at this stage you could rearrange it, but I'll just type into the equation solver to get your answer. I'll leave you to do that. It effectively ends up being 1 over 1.52, and those of you who did IGCSE will remember the equation sine c equals 1 over n, which is effectively what you're using here. But you don't need to do that. Just remember this, and remember the fact that this angle is 90, and this will normally be air, so this will be 1. Some of you got these the wrong way around. If you get a calculation error, just swap them around. Then we had a question like this in the test. So you can see it was taken from the 2021 paper. Again, I'll give you just a moment to read the top of that. So emerge as parallel beams. Identify the type of lens. Well, remember this one's larger in the middle. See from that shape there. So that one is a convex lens. And then don't forget, some of you always forget to read the second part. Where would the lamp be positioned for it to come out parallel? Remember, that has to be at the focal point, or at the focal length from the mirror. That's when it goes out parallel. Because if I did this the other way around, you'll remember if we send in parallel rays, they all meet at the focal point. So we're just doing the opposite. We're going this way. So that's what we see. Now I can simplify to 2. Now here, this question caught some of you out because it says accurately to show how the light travels as it enters and exits the lens. So let's go step by step. Now we know they're going to come out parallel. So somewhere over here we're going to have them coming out parallel. But we'll draw that bit in a second. So now we've just got to focus on what happens initially as it enters in. Now there's the normal, and it would just continue like that if there was no refraction, but it's going to slow down and it's going to bend towards the normal. So we get something like that. If we then draw our next normal, which is something like that, it's now going to speed up because it's going from glass to air. So it's going to bend away from the normal. You can see now how that kind of ends up with it going parallel. So it's slowing down towards the normal, speeding up away from the normal. And we know they come out parallel, so we've got to do them parallel. That second one's not great. Probably do that slightly better, something like that. So there was marks for realising that you had to refract it twice. One on the way in, towards the normal, one on the way out, away from the normal. And then you've got also some recognition if you realise they went parallel afterwards. Then we had this question. Show the refractive index of the acrylic is 1.5. So, we know the angle of incidence. Remember, it's going 1 to 2. So it might be worth writing out this equation at this stage. Might not be useful. And actually, as you notice, that's not useful in this case. That's going to be useful down here. We were working out angles. So it's not that one. But we had a go. We've got the speeds. And we've got refractive index of air. So remember, we've also got this equation, n1 over n2 equals v2 over v1. Now it's just a case of putting our numbers in. Remember, the 1 refers to the first material, so that's air. So I'll just now get the things for air. Refractive index is 1. For glass, we want to find that, so that's n2. v2, remember, is the speed in acrylic, which is 2 times 10 to the 8. And in air, it's 3 times 10 to the 8. We've got that there. So I just put that into my equation for solver, and I'll get a value for the acrylic. It should be greater than 1. I'll let you type it into your equation solver to work that out. Calculate the angle of refraction. Well, now you've got that answer. And remember, if you couldn't get it, just have a go, get a number, so you can do this question. Now we want the angle of refraction. Again, 1 just refers to the air, 2 refers to the second material. So the 1 for the air is 1. Sine the angle of incidence, which is 30, equals our answer up here. Let's say we get 1 point. Sorry, it does say show that. So you've got the answer. You can have a go at this. So I'm going to just put that in there, 1.5 times sine the angle of refraction. Again, that goes into your equation solver. And remember, look, this is going to be smaller because it's bent towards the normal. So we're expecting to get an answer of less than 30. If you get calculation error or some ridiculous answer more than 30, you've typed it in wrong, or your calculator is in radians. Just reset it so it goes to degrees. Then we had questions about lenses, about mirrors, which somebody struggled with. Now I'm going to focus on the ray diagrams for these. And the key thing to remember, it's a mirror. So a lot of you are doing lenses and doing some lovely stuff like this. Ray comes in parallel, great start. Thought it was a lens, so then did something like through the focal point or like this, but it's a mirror. Okay, there will be no rays behind the mirror, so the only things you can draw behind the mirror must be dotted lines. It's got to bounce off this. This line represents the mirror, and it is convex, which means it's going to ping the light outwards, diverge it. Now remember, what you do here is you line it up with the focal point like this, and draw it going off like that. So that's one ray done. But remember, you always need a second one. Now for mirrors, always do, and for lenses, always do one to the middle. If it was a lens, the middle one just goes straight. But remember, this isn't a lens, so we know that we've got to use our protractor to measure this angle, and that's why I gave you a protractor in the test. That's the angle of incidence. Then mark it over this side and just bounce this off so that it reflects on the mirror. Remember, there should be no rays behind the mirror except for dotted lines. Now in this case, your eye is over here, and it sees this ray and this ray coming to it. So what does it do? Well, it dots back along in a straight line to see where they meet, and that tells you the image is here. Now, common exam mistakes were some of you drew your image like this. Oh, it's not showing me. Some of you did your image kind of like a little arrow or did a bigger arrow. It's got to be really accurate. The arrowhead is where they meet, and it goes down to the line. So don't just do a really lazy arrow, something like that. Make sure you label it as image as well. You've got to draw that arrow to get the marks, because otherwise I don't know where the image is. So we can see there that that is creating. This is the original, this is the image, so it's going to be diminished or smaller. It is virtual, because we had to dot back, and it is upright. So they're the three state, the nature. So just be really careful in the exam. Check if it's a mirror or lens. Mirror, light reflects off. You can dot back behind, but no rays go behind. Always do the one that goes parallel, and do the one that goes to the center, and you're going to have to use your protractor. And then this one asks why a concave mirror is no good. Now this is where you need to know the nature of the image produced by concave. So remember, concave is shaped like that. Remember, when the object's nearby, it's magnified, but obviously in a car, you're looking at distant objects. And you might remember when you do the ray diagram that makes them smaller, which is fine, but it also makes them inverted. Not good if you're driving, because it's quite hard to imagine if a car's in the sky or on the road. So that's why you've got to remember what the nature of the image is, but then you've got to explain it. Some of you were good at this, some of you weren't, but you need to say something like, it would be useless in a car to see an image inverted because you need to respond to what you see, or something like that. So try and explain it with a bit of meat on the bone there. Okay, hope that was useful. Keep practicing questions.